we just discussed story problems that do have action, but what about story problems that don't have action? How do we categorize those? And so the first thing we did is, so just like we asked that question, is there an action? If it's not joining, if it's not separating, then we ask ourselves, is there one set with two parts? And so this is very similar to the join result unknown story problems, because some people say, oh, well, it's the same story problem. And so let's take this example here. We have this picture of a shelf, and there's these books on a shelf. And so some of them are math books and some of them are science books. And so what if I were to say there are 3 science books and there are 6 math books? How many books are on the shelf altogether? So some people would say, well, you just take the 3 plus the 6 and equals 9. And that would say, well, that's a join result unknown story problem. But the problem is that I'm not adding extra books. I'm not taking any extra books away. I have books on a shelf, and there are these 2 sets. Some of them are math books and some of them are science books. And so we call these part, whole story problems. And I do want to say, again, make this distinction because kids see this very differently. Again, sometimes some kids will just have them build each set, but they may not know what to do with the set because there's nothing in the story problem that's telling them to add them or subtract them. And so sometimes, especially when we think about, if I were to ask the question, say, there's 9 books on the shelf, 3 of them are science and the rest are math. How many are math books? There's one part of the story problem that's missing. That tends to be a little bit more challenging because there isn't an explicit action that's happening in the story problem. So again, if there is one set with 2 parts and nothing is being added and nothing is being taken away, then this is considered a part, whole story problem. Another non-action story problem we can ask is, are there 2 separate sets being compared? And so, for example, if we take a look at these pictures, we have a group of balloons here on the left, and then we have another group of balloons here on the right. And what we can ask is, what do you notice about these? We notice that the one on the right is there's more balloons than the one on the left. And so if we want to compare those 2 sets, then these are our comparison story problems. So again, it's 2 sets that are being compared. A lot of times what people will do is they'll try to combine the sets together, and it just is a little bit more complicated for students because they see them as 2 separate sets rather than one set that we're just taking parts off. So these problems, the part, whole, and the compare story problems, these are static. There's, again, nothing being added, nothing being taken away. And unlike the action problems, we can tell a picture, we can use a picture to tell the story. Whereas with the action problems, it's almost like a movie. It's this kind of things that change over time. There's nothing changing here over time. So it's just the groups, either 2 of them being compared, or there's one set that has these 2 parts that are being combined to make the whole. And so if you go back to your card sort, you may notice that there are 6 of them that do not have action. So thinking about those, which one has the one set with 2 parts and which one has the 2 sets that are being compared. Again, one set with 2 parts is our part, whole problems, and our 2 different sets are our comparison problems. And I think that's, so the action of the unknowns, story problems, the unknowns and the non-action story problems, again, it's which parts are unknown. And so for the part, whole, because there's these 2 parts, we can either have the whole missing. So we have the 2 parts, but we don't know how much we have altogether. We can have one of the parts missing, or we can have both parts missing. And these both parts are actually pretty fun for to pose to kids. This is actually a really good story problem to pose to kids, especially in 1st grade, where they have to know the different combinations that make 10. And so this is a nice way to kind of put that problem in context rather than saying, what are all the different ways that you can make 10? You can ask a problem that says something like, I have a vase with flowers, some are red and some are yellow. All together, I have 10 flowers. So how many of each could I have? And so then it makes them try to think about all of these different combinations and think about also this idea of, is one red flower and 9 yellow flowers the same as 9 red flowers and 1 yellow flower? So again, so they can start to see that commutative property of addition, and that even though you just flip-flop the numbers, they call them flip-flop facts, but we really want to call them, really want to talk about this commutative property, that it's the same numbers, but the situation is very different. With the compare problems, we have these two different sets that are being compared. And the difference is is when we have both, we know the amount of each set, we're just trying to see how much extra the one set is. And then either one of the quantities for the sets can be missing. I will, going back to our chart that has the story problems, I will say that these story problems are on the bottom of the chart, which means that they are more difficult than the top part of the chart. Again, the top part has action that's happening. The bottom part does not have action. So it's a little bit more challenging sometimes for kids, where they will build the sets, but they're not quite sure what to do with them next. And so again, these, it gets more difficult as it goes across. And so our compare referent unknown story problems are the most difficult problems. And so I'll read it for you. So Connie has 13 marbles. She has 8 more marbles than Juan. How many marbles does Juan have? And so I will say that with these compare problems, many people will try to, many teachers will try to support kids by helping them with keywords, right? Especially for our compare difference with how many more. Some teachers will say, oh, you just subtract. I want to caution you about trying to support kids by using keywords, especially for this particular problem down here. If kids solely rely on keywords, they will get this problem wrong. Because what kids will say was, oh, she has 13, she has 8 more than Juan. And so what they'll do is they will add these numbers together to get the amount that Juan has. But if we think about this, we have to think about she has 8 more than Juan, meaning that her amount is already larger. If we were to add these numbers together, that would mean, and say that that's how much Juan has, then he would have more than her. So we have to try to support kids and have them reason and think about who has more and what does that mean if she has 8 more than somebody. And again, if we were just to use those keywords, the kids would just grab onto that idea of 8 more, and they would add that number together, those numbers together, and they would get the incorrect answer. So again, just a word of caution on keywords and thinking about how we might support kids. And again, thinking about the context and thinking about how they might make sense of these ideas. And one last thing that I wanted to share is that also on Canvas, I wanted to share this chart. This was actually created by a former student of mine. She was in the master's program last year, and she created this little chart to kind of help her, like a little tree diagram, to think about, is there action in the story problems? Yes. So is it a join or is it a separate action? And then it can be any of these problems here. If there's not an action, is it one set with 2 parts? And then what's the unknown? If we're comparing 2 separate sets, then which ones could it be? So just another resource for you. Oops, let me stop sharing here. I don't think I'm not sure if it came up or not. But again, so again, if there's an action, is it a joining or separating action? If not, is it one part? Is it one set with 2 parts, or is it 2 separate sets being compared? So just wanted to share that with you as a resource and to help you all think about these different problem types, because kids will solve them in lots of different ways. And so we want to be sure that that also kids will solve them in very predictable ways. And so if kids aren't solving them in those predictable ways, it's going to tell us a lot about their thinking. And so we're going to talk about that in the next section. So thanks so much.